Hello there, this is Mrs. Butcher, and this video is 4.2, Graphs of Quadratics in Vertex and Intercept Forms. So just as a quick review, yesterday we talked about standard form being y equals ax squared plus bx plus c. Vertex form looks like this. So your parent function is y equals x squared, and then we're applying transformations to that. You have this a value here, you have this minus h thing in here, and you have this plus k here. So the a stretches your graph by a factor of a. Stretches or shrinks, I should say, because if it's like a 1/2, then your graph is going to be half as tall as it was before. All right, the minus h is your horizontal shift, and the k is your vertical shift. So if you think about it, when I take this graph, when I stretch it or shrink it, the vertex doesn't go anywhere. But then when I move a parabola over h and up k or down k, my vertex ends up being at from 0, 0 to hk. So that's why we call this vertex form, because the vertex is clearly evident in the equation. Okay, so we are now going to graph y equals negative 1/2 times x plus 3 all squared plus 2. And before we graph this, I want you to think about what the transformations are. What does the negative do, first of all? This negative means that we're going to have a sad parabola. It's going to reflect it over the x-axis. This 1/2 here tells us that it is going to be shrunk by a factor of a half. And think about what would happen if you took that parabola, put it between your hands, and squished it. It would look fatter. So when we shrink a parabola, it looks fatter than the original. This plus 3, if it's supposed to be x minus h, then this is x minus negative 3, isn't it? So that means we're moving negative 3 units. We're going left 3 units. And then the plus 2 means we're going to move up 2. So now that we've thought about that, to graph a quadratic that's in vertex form, the first thing that you want to do is you want to look at it and you want to find the vertex. And in this case, it's negative 3. Remember, it's always the opposite of whatever h is because it's x minus h. And then 2. Negative 3, 2. So we're going to plot that. There. Sorry, I don't have a ruler on my iPad. So negative 3, 2. Once you've plotted your vertex, and we know this one's going to open down, all you have to do is make a table for yourself and pick x's and plug them in and solve for y, just like we did in standard form. So if I picked x is negative 2, the next x over, then I'm plugging a negative 2 into the equation for x. And so I have negative 1/2 times negative 2 plus 3, which is 1, squared, which is 1. So negative 1/2 plus 2. 2 minus a half is 1 1/2. So I know that when x is negative 2, y is 1 1/2. All right, and then I can plug in the next one, negative 1, and do the same thing. And negative 1 plus 3 is 2, squared is 4. Negative 1/2 times 4 would be negative 2, plus 2 is 0. So we have a point here at negative 1, 0. And because I know that parabolas are symmetric, I can just mirror each of those 2 points to the other side, and now I have my required 5 points plotted. And if I were asked to label all this stuff, this would be our vertex. If I asked for the axis of symmetry, make sure you tell me it is x equals negative 3, because it's a vertical line, so we need that axis of symmetry written in the form of a line. If I wanted the x-intercepts, this one has nice clear x-intercepts, so we could write those 2 ordered pairs down, negative 1, 0, and negative 5, 0. If I wanted the domain, see these arrows? That means it goes forever to the left and forever to the right. So my domain would be negative infinity to positive infinity. And my range, these arrows both mean it goes forever down, so it's starting at negative infinity, but it does have a maximum. It does have a top at y equals 2. And it touches it, so we want a hard bracket on that too. So that's how you graph a vertex form equation. All right, now another example of something you would be asked to do is if I gave you the vertex and then another point, I'm going to ask you to find the equation of the parabola without a calculator. So here's what you do. You say, well, I have the vertex, so I'm going to write vertex form, y equals ax minus h squared plus k. So yeah, you do have to have that memorized. And I know the vertex, so I know h and k. So I'm going to plug those in. I also have a point, and so a point is always x and y. So I'm going to plug those in, and now I have all the letters except a. So now I can solve for a. So I'm going to plug them in. The y is 5 equals a times x is 4 minus h is 2 squared plus 1. So 5 equals 4 minus 2 is 2 squared is 4a plus 1. Subtract 1, 4 equals 4a. That means a is 1. So now I have all the pieces I need. I have a and h and k. And I can write the equation y equals 1 x minus 2 squared plus 1. So you keep the h and k in there. The y and x go back to being variables. All right, so let's take a quick break. Here's a little joke for you. Chris Fong in my 5th period class requested a joke in this video, and yeah, this is what me and my nerdy math friends do in our spare time. All right, Chris, you happy now? Okay, moving on. Now we're going to talk about intercept form. That's also known as factored form, and its basic form is y equals a, and then x minus p, and x minus q. So your x-intercepts, that's when y is 0. And if I were to set this all equal to 0, then either a has to be 0, which isn't going to work, or x minus p has to be 0, which means that p is x, right? Or x minus q equals 0, meaning that q is x. X equals p, x equals q. That means we have x-intercepts at p0, and we have one at q0. So it's called intercept form because your intercepts are visible right here and right here. And so you could plot those 2 points on the graph, and then you could go halfway between them to find your axis of symmetry, plug that x value in to get your vertex, and then go from there to graph the graph. So let's just do one example of that real quick. All right, this time we're going to graph y equals 2 times x plus 2 times x minus 4. So that means that our x-intercepts are at negative 2, 0, because it's always the opposite, and positive 4, 0. So I'm going to plot those on the graph, just like that. So now I know that I have this parabola with an axis of symmetry halfway between here at x equals 1. Axis of symmetry, x equals 1. These are our x-intercepts. So if I wanted the vertex, I would just need to plug a 1 in for x here and here. So 2 times 1 plus 2, 2 times 3 is 6, 1 minus 4 is negative 3, 6 times negative 3 would be negative 18. So my vertex is at 1, negative 18. You're just plugging that x in here and here to get y. So that's way down here. Alright, so I've got 3 points plotted. I need 2 more to make this official, so I can pick anything I want here to plug in. 0 is a nice, easy thing to plug in. So 2 times 0 plus 2, 2 times 2 is 4. 4 times negative 4 will be negative 16. So I know I have a point at 0, negative 16, which is going to be right here. And of course that mirrors over the axis of symmetry. So now we have the required 5 points for this big skinny parabola. We've got it graphed. We know the x-intercepts. We know the axis of symmetry and the vertex. We could also figure out the domain and range. Domain, all real numbers, negative infinity to positive infinity. The range has a bottom at negative 18, and it touches it, and then it goes on up forever, so negative 18 to infinity. All right, so that's graphing. All right, now, what if I gave you x-intercepts of negative 1, 0 and positive 4, 0, and I gave you a point, 3, 2, on this parabola? That is enough information for you to be able to write the quadratic equation. And just like we did with intercept form, you just write down the standard standard intercept form. So y equals a times x minus p times x minus q. And then we look and we've got p and q. It doesn't matter which one's which. And then we have a point, we have x and y. So we plug in x, y, p, and q and solve for a. Right, y is 2, a we don't know, x is 3, p is negative 1. So if I say x minus negative 1, I'm saying 3 plus 1. And then x minus 4, whoops, not x, 3. X is 3. Got to put the number in there. Sorry about that. So we've got 2 equals a times 4 times negative 1. 2 is negative 4a. A is negative 1/2. You have to solve for a because there's always going to be something in front of there. Sometimes you're lucky and it's 1, like in the last problem, but sometimes it's not. So now we can write the equation y equals negative 1/2, and then x minus p would be x plus 1, and x minus q would be x minus 4. So you put x and y back in as variables with your a and your p and your q plugged in. So yeah, that's all I have for you today. You guys have a great evening, and I'll see you in class tomorrow.